Good morning, dear students. Welcome back to physics class. Today, I would like to discuss on two topics. They are A. Are various forms of energy interconvertible, and B. Law of conservation of energy. In the beginning of today's class, at first, let us discuss on the topic, are various forms of energy interconvertible? Now, I ask you one question, are various forms of energy interconvertible? Definitely, it can be interconvertible, that is, it can be converted from one form to another form. You can find out number of examples to show the conversion of energy from one form to other form. You can give the names of various natural phenomena wherein the interconversion process of energy takes place. For example, green plants prepare food. They need energy to carry out this process. You know that this process is called photosynthesis. Where do they get their energy from? You can say that it is from the sun. They use the solar energy to make the food. During the photosynthesis process, the food prepared by the plant is carbohydrates, which is a source of chemical energy, that is, the plants convert the solar energy into chemical energy. The figure shows a coal power plant which uses a technological method to convert one form of energy to another form. Here, it converts chemical energy into electrical energy. You know that fuel is a source of chemical energy. When the fuel is burned, it has produced heat energy. This heat energy is used to produce steam by boiling water, and the steam is used to rotate the turbines to produce electrical energy. Then the conversion process is the chemical energy is converted into heat energy, and in turn the heat energy is converted into electrical energy. Many of mechanical or electrical devices or gadgets use the conversion process of energy from one form to another form. Examples: when a bulb glows, it uses electrical energy and converts it into both light energy and heat energy. When TV is running, it uses the electrical energy and converts it into sound energy, light energy, and heat energy. In the working of these electrical devices such as fan, washing machine, etc., they use the electrical energy and convert it into mechanical energy, sound energy, and heat energy. There is one question: what happens to the total energy of a system during or after the process? Whenever energy transformation takes place, the total energy of the system will remain unchanged. It is a constant value. The law involved in this process is called the law of conservation of energy. According to law of conservation of energy, energy can neither be created nor destroyed. Energy can only be converted from one form to another form. The total energy of a system will remain unchanged. That is, the total energy before and after the energy transformation remains the same. The law of conservation of energy is applicable in all situations and for all kinds of energy transformations. A ball falling freely from a height, at height h, it has only potential energy. It is equal to mgh. Its kinetic energy is equal to 0 because its velocity is equal to 0, since kinetic energy Ke is equal to 1 by 2 mv square. Then total energy of the object is equal to mgh. As the ball continues to move downward, the potential energy would decrease while the kinetic energy would increase. By the time it is about to hit the ground, the height of the ball above the ground h is equal to 0. So, it has 0 potential energy, but as it has a velocity, it has kinetic energy is equal to 1 by 2 mv square. Therefore, energy gets transferred from potential energy to kinetic energy, while the total energy of the system will remain unchanged. Thus, it can be written as total energy of a system is equal to sum of both potential energy and kinetic energy is equal to mgh plus 1 by 2 mv square. It is a constant. Answer the following questions. First question is, the potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? Why? Answer is no. This process does not violate the law of conservation of energy, because when the body falls from a height, then its potential energy changes into kinetic energy progressively. A decrease in the potential energy is equal to an increase in the kinetic energy of the body. During this process, total amount of mechanical energy of the body remains unchanged. That is, it has conserved, which is in accordance with law of conservation of energy. Second question is, what are the various energy transformations that occur when you are riding a bicycle? Answer is, the muscular energy of the cyclist is converted into rotational kinetic energy of the pedals of the bicycle, which is transferred into its wheels. Due to this, the bicycle wheels move forward. When the bicycle moves, then the bicycle as well as the person riding the bicycle both have the kinetic energy. And third question is, illustrate the law of conservation of energy by discussing the energy changes which occur when we throw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happened to its energy eventually? Is it a violation of the law of conservation of energy? As shown in given figure, at the points B and C, the pendulum bob is at its maximum height. So, its potential energy is maximum due to this height, and kinetic energy will be equal to 0 when the velocity of the bob is equal to 0. In this way, the total mechanical energy remains constant. At the point A, the pendulum bob is at its lowest point. So, the potential energy is equal to 0 when the kinetic energy is maximum because the bob has maximum velocity. Thus, the total potential energy has been converted into kinetic energy when it reaches to the point A. Once again, the total mechanical energy remains constant. Why does the bob accidentally come to rest? What happens to this energy eventually? During each collision, some energy gets transferred to the air due to overcome overall friction. So, kinetic energy of the pendulum is lost due to the air friction and the pendulum stops eventually. However, the total energy of the system will remain unchanged. So, it does not violate the law of conservation of energy. I have to remind you this point again. Law of conservation of energy. What is law of conservation of energy? Energy can neither be created nor be destroyed. It can be converted from one form to another form. The total energy of a given system remains unchanged. That is, the total energy before and after the transformation remains constant. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.